So we discussed in the last video this issue of if can warping moons break, and we said yes they can. So the setup, of course, if you have a planet like this, all planets have a radius, say radius of the planet. There's a certain point right here, and this point here is 1.26 times the radius of the planet. So again, if you come out 26% farther than the planet itself, there'll be a zone right here that these moons and things that might be orbiting will break. Where if you get farther than that limit, say if you get onto this region right out here and beyond here, then you'll just sort of warp. This is where the warping can happen. And my drawing is greatly exaggerated, so I'm just saying that a nice round moon like this might start to warp like this if it's outside of 1.26, where it'll break. And this limit here is called the Roche limit. RO is the Roche limit. And so that might very well be one of the reasons why Saturn has moons, the other primary reason. Here's sort of a graphic of everything happening here. So you see as you're sort of far away from the planet, you can stay nice and round. Maybe the gravity isn't even pulling you that much. The warping is minimal. As you get closer, you can start to warp more. That's what happened to our moon and poor Io. But as you get inside the Roche limit, you're going to break, period. Something like that, okay? And so here's sort of a computer simulation of what can happen here. Is I think in the simulation what they did is they brought a nice round object here outside of something maybe like the sun or a planet. They kept it outside. Here's the Roche limit right here. Kept it outside the Roche limit. And again, this distance right here is that 1.26 times the radius of whatever planet we're talking about here. And they kept it outside, but as they brought it closer, started to warp. And as they hit that line, as they hit the Roche limit line, it started to shatter. Why does it shatter? Of course, just because of gravity again here. Here, F sub G is just too strong. Too strong for the rocks either to bind together or gravitationally stay together in the planet. And over here, gravity is kind of weak because it's further away, and the planet just pulls apart. And so you can see it starts to break. And when it starts to break, of course, is all the particles and constituents of the moon start to sort of stay in orbit. It's not like those are going to leave orbit like that. The blue ones that broke apart on this side are going to stay here. The red ones are going to stay here. And they just enter their own orbit around the planet. They're all broken up, and they just start to orbit, maybe happily going around that way. And so that may very well be what these beautiful rings are here. These rings might be an old moon that hit the Roche limit, broke apart, and its constituent parts are forever orbiting, causing the rings of Saturn. So that may very well be what happened to give us Saturn's rings.